This will probably be somewhat of a break from technical talk. A lot of the topics here are more, I don't know, presentation-like, but I'll save some time at the end. You can stop me in the middle, but probably won't. And we can, I'll get to the technical stuff towards the middle of the presentation. So UCX development in Huawei, I intentionally put here a more big picture kind of presentation. I'll have, we actually give a couple more later this week. So I'm gonna start with kind of an overview. I gave it the title of cause and effect because I kind of have to say, okay, after all these technical talk, it looks like a bit of a marketing speech. Trust me, it isn't. The reason I put some of these slides here is to demonstrate the cause for some of the other technical decisions we've made. So I get sometimes when I talk about the stuff we implement, people ask me, well, why did you do that? That's odd. So I kind of feel I need to provide some motivation. So a lot of slide decks have this slide saying, yeah, we do all levels of HPC, and clearly Huawei also tries to cover the entire stack, so much so that when I joined, I found out that Huawei has their own compiler development, and I was like, well, you have some pretty decent compilers out there. Why are you working on your own one? And I pretty quickly figured out that that's actually pretty useful, and they have a lot of interesting accelerations we in turn use in our software. So one thing that may be more special about Huawei and my personal work, including UCX specifically, is that our server often looks like this. So if you look close enough, you'll see that most of the components are made by Huawei. Maybe some exceptions do exist, but from CPU, which I'll talk about a bit more, down to hard disks, which I will not mention at all after this slide. One of the challenges we have, and one of the goals of my team, is to kind of how to make a lot of the stuff that is done for x86 to be general, and for specific NIC vendors to be more specific, how to make this work well on our hardware. And obviously this yields a lot of optimizations that are good for any hardware vendor. So this is a product evolution slide I stole from the guys who are talking about CPUs all the time. I'm not going to go into details on this, but I am going to say Huawei, among others, has its own CPU, an ARM-based Kunpeng 920. That's the latest version that has been released. And I actually feel kind of it's important to say, yeah, we've been doing CPUs for a while now. It's not like we just released our first one. So there is quite some work done internally on this, and only now becomes more open and public as these CPUs hit the consumer market. So does the software. A bit on this. There's a lot of figures here. We improve this and we focus on that. If I had to highlight something, I'd highlight the 64 cores. The reason I highlight it is because it drives a lot of our decisions with respect to resources and memory consumption, and some of the way we manage the software to try to make it adapt to like a higher PPN than anything we see on the traditional servers that we have. We also keep like regular servers, obviously. And we have some various servers. I'm not going to talk about their qualities, but I am going to say that if you combine 64 processes, 64 cores with this guy on the right, not guy, sorry, server, X6000, you end up with 4 CPUs, 64 cores each. That's 256. processes or ranks running on the host. This is probably very different from what we used to see so far. So again, I'll show how this translates to software later in my talk, I hope. I want to kind of talk about components because this also often drives like the way we work and also affects the way we develop, including UCX specifically. And this is to say, okay, we're kind of targeting memory-bound application. If you look at the arithmetic intensity, which is not something we invented, obviously, it's been there for a while now, and kind of measures what's the bottleneck of the application on this axis of memory to compute. And I am going to say like, okay, look, this is more memory bound, this is more compute bound, but obviously that's not the only axis, and we didn't talk about network, and we didn't talk about tons of different features and dependence on data sets that applications have. That's just to kind of show where we're going with this. And by this, I mean both the development in UCX and with as a company strategy, which I don't decide, I just implement. So this kind of helps explain the reason we do some of the stuff we do. This is a partial list of the applications. Obviously, nobody will go over it. Just here to kind of clarify. Okay, we really look at we try to look at applications and kind of rank them by arithmetic intensity to show to see what's worth our focus and effort. Obviously, other business considerations are kick in at some point, maybe above my pay grade, but still. And obviously, this depends on the input and settings. I think I talked enough about the compute. I'm going to start talking about network, I promise. This is a very recent publication, not in the sense that it's a paper. Maybe there is, but I'm not aware of such. Huawei now does in-network computing as well. You probably know of other vendors who will not be named at this opportunity that do some kind of a MPI offload and specifically reduction on the switch. Well, as far as I know, Huawei is the first one to do it on a RoCE-based switch that is available, and you can purchase it if you want, if you don't have any, trade restrictions and limitations. So not my work. I'm just kind of showing some of the stuff. Actually, a lot of the requests I get internally inside Huawei is, oh, Alex, we see you're kind of working on this UCX project. Could you help us integrate this? So it is not unlikely that one of the projects I'll have like in the coming months is to help create a UCX transport to kind of send messages to this thing, which as you can see on the screen, kind of takes the packets away on the switch. Like it actually fits in the hardware, and it does some reductions. You can see nice results on the right. It might be a bit slower than what you would expect, seeing as other vendors use interconnects that are not RoCE. So we do have this working against us, but we do see a nice improvement and obviously a nice selling point for what appears here to be Huawei Mpi. I'm going to talk about that later, I promise. One other thing that's probably worth mentioning is that the Kunpeng CPU has, at least the latest model, has a built-in, so part of the CPU package is a built-in NIC that is capable of RoCE communication. I put the picture here kind of to, I wasn't sure like how marketing like the slides would be, so I kind of put a break here. But the idea is a lot of the times we see that in some application patterns, you have a lot of cores, a lot of requests going in the direction of the NIC. So that's the illustration at the top where you see all the sheep kind of trying to get through the fence. And we find that in these patterns, this solution of onboard integrated NIC on the CPU die actually helps ease this bottleneck. Obviously, good for some cases, not so good for others. And one of the things we're working on is to kind of detect it and try to see when we should use this. And in a lot of cases, we actually have, in addition to this NIC, we also have a NIC from either one of the other vendors out there, or we also have an RDMA capable NIC that is like a separate package, like you would traditionally expect. So this actually very much related to these 64 cores per CPU we see I mentioned before, and it actually is it actually looks a mess if you look at the PCI traffic when you get all these cores trying to communicate simultaneously. So obviously there were other considerations on doing this kind of architecture, but I am obviously trying to highlight some of the benefits of doing things the way we did. If I'm touching on system performance, so Huawei is not very well known in the HPC area as like building big supercomputers and stuff like that, but I have recently gotten this good news, so obviously I put it in my slides for posterity. Huawei built a system with a lab in China. I think it belongs to Tsinghua University, but don't take my word for it. Please go read the PR if you're interested. And we actually got very nice results on IO 500. We are now #1 both on the IO 500 list and on the 10 node challenge, with like very nice margin from the second and third runner-ups. And what I wanted to say about this is they didn't publish it, so it's not like an official release, but you can tell everybody you heard this from me. Actually don't, China will be angry. It's actually using UCX for the communication. I didn't, there are a lot of stuff we're developing that are kind of crawling in the direction of either upstream or being released officially as a Huawei package. But this already uses UCX. I actually got like, one of these, the client urgently needs your assistance with something. So I actually helped them. I solved some problems they had not related directly to UCX, but you should know that it's certainly in use and is helpful. So now I'm kind of getting more to the stuff that I wanted to talk to you about, which is what we do in Huawei, which directly goes to UCX, or Mpi, which is kind of right on top. So there are two slides, one after the other. One is when I joined Huawei, which was almost 2 years now. No, a bit above 2 years now. So when I joined, they were like, yeah, we have all these plans. We're going to do this and that, and the tool chain I mentioned, and the Huawei Mpi, which is now, by the way, called Hyper Mpi. I'm not sure I changed it in all the slides, obviously not. But today it looks like this, like all the boxes are checked. We have the Mpi, and some of the compilers and libraries are already available online. And yes, that means our build of UCX is actually built with these compilers and has some customizations for our platform, but I'm not personally responsible for this, so I'm not gonna go into that detail. Huawei also has some like adjacent middleware, like they develop their own job scheduler, and they have resource management, maybe somewhat similar to PBS. The product is, I'm not sure it's public yet, but it will be at some very sometime very soon. And one of the reasons is because they are working tightly with the cloud business unit of Huawei to make some of these services available on the cloud and for the infrastructure of said cloud. But also, obviously, because Huawei makes a lot of the hardware it sells on its own and doesn't kind of buys white label equipment, there is a lot of work done tailoring some of the software I'm responsible for in Huawei and some of the other related middleware packages to that hardware. So that's actually a lot of my talk is going to be about that. And what's not going to be there is some proprietary stuff we didn't publish yet. And I'm going to talk about that a little later in this talk. So yes, zooming in on UCX today. So gentle reminder, this is UCX, everybody here knows that. I'm gonna talk like briefly about stuff we do in each layer. This will be mostly, I'll start with stuff we already submitted and we're mostly upstreamed, and then I'll move on to stuff we're still working on, and I'd be happy to hear your feedback. Obviously, some of the guys on my team are actually on the call, so if you badmouth the work, they may get offended. So don't. Just kidding. Stuff we did on the lowest level of UCX, probably the services. So Shuki worked on the pointer array and they accelerated it with some. We actually took out some code that wasn't longer used, some bits that were available for optimizations, and now we have a very impressive increase in iterating on a pointer array, like if you do a for each on them. And we have also some prefetching trickery to thank for another small boost on x86, but that's probably test specific. I'm not sure I can promise this on every test you run. The rationale is actually we're using it in UCG to have some kind of a ring buffer. We do some kind of tag matching in UCG without using the hardware to offload it. So we place pointers to messages in a pointer array. So it makes a lot of sense to us to accelerate looking through them. Lately, we've been doing some work on statistics. Shuki will actually give a talk later this week about that. And the way we started is we wanted to collect UCX information, and by information I mean stats, and actually do something useful with the numbers. I'm not gonna steal his thunder, so I'm just gonna say that we found some challenges in the way they are collected, these numbers, and also like how we could process them. And it's important to us because we feel like a lot of the benefit that we can achieve in applications is actually from understanding what happens on the UCX level and kind of trying to make it better. Well, at least we have our fingers crossed on that one. Miscellaneous stuff, timer queues, allocated aligned realloc, GCC fixes, stuff like that. We're always happy to help. If it's something we're doing anyway, might as well help everyone. UCT, most
Alex,
of my, yes.
Can I interrupt you and ask a question before?
Sure. Go ahead.
Too far away. So I had a couple of pending questions. You showed like CPU and NIC on the same SOC with a NIC connected through PCIe. Do you have actually any comparison numbers?
I'm afraid by the time I had to have these slides ready, which is like now, I did not receive confirmation to kind of publish results. So I'm afraid I can't. And I'm waiting for the guys who the guys who are working on this. Even I can say there is a UCX transport for the 1620 RoCE. I gave them some advice on the implementation, but it's implemented in China, and the status is like work in progress. So I can't. I don't have a lot of control over when this is going to be published, but like it's in the microseconds. It's not like it's good latency, and like we're happy with it. So we're going to use it going forward.
Okay. Well, I even wasn't specifically focused on transport implementation. It just was, well, it's better to compare it with the same software environment. But yeah,
yes,
I was just curious about having NIC on the package vs on PCIe. And the following ones is IO 500. What CPU is used on this machine? It's
the Kunpeng 920. I'm not sure if they published it as part of the press release, but like the problems they asked me to help with are stuff that could have been related to communication because of this 1620. But 1620, sorry, I didn't mention. It's the internal name for the product. It's not secret. It's just not the brand name. So I did some work. I saw the code, but I'm not in the team developing it, so I can't have. I don't have.
It is ARM based, and I guess with RoCE Interconnect as well.
Yes, ARM based, RoCE Interconnect.
Thank you.
Sure. So actually, most of my time personally, that is not to say about the rest of the team, but my time is mostly on UCT transports. A lot of you probably know that I have a lot of work done on collective operations. That's a separate talk. So I only say I'm doing one-to-many communication, and that's a spoiler alert because there's going to be a different talk. That's also why I was interested in the active message ID range. I am abusing it, I admit. Kunpeng RoCE support. They also, by the way, have a lib RDMA lib. I think it's lib HNS RDMA. There is a provider in RDMA core for the 1620 RoCE, but there are also some specifics and optimizations that are not upstreamed yet. They will be upstreamed. No reason not to. Just still work in progress on that. So I'm kind of helping them, even though it's not in my hands. RoCE reachability issues. We've had quite a few of them in the lab. There's a pending PR. I know I need to spend more time on it, but I wanted people to know it exists and it's important to us. So here's the basic description of the problem. If you have two RoCE ports on the same subnet, what do? Do you either set both IP addresses on the same subnet? This drives Linux a bit bananas because how do you choose the TX port? Like you have a conflict. Both of them kind of cover the same subnet, and you have problems like packet should have arrived on this port and arrived on that port. And to make things complicated, we have socket direct, and it makes socket direct a bit unhappy. On the B alternative, you kind of set IP addresses on separate subnets, and then you can kind of control, okay, if it's on this subnet, it's this IP. If it's on that subnet, this port is on that subnet, and the other port is on another, and then you can control the way packets are sent. But then obviously you have a problem, like if you kind of explicitly need to control this to control the way the packet goes, and in some cases you cannot communicate with other ports. This description came out not as clear as I hoped it will be, but we kind of felt in a catch-22, and because like either option has its problems and didn't fully work for us. Current workaround, ask for RoCE v1. Actually, there's no direct way to do that. You need to know your Mellanox hardware, and you need to ask for IBGID index equals 0, which is magic speak for RoCE v1. And link aggregation is not a workaround for various reasons, but we don't want that. There is a PR has been submitted a long time ago, and I kind of neglected it. Sorry, but it kind of detects this ugly situation and chooses RoCE v1. It's important also because we're kind of experimenting with interesting network topologies, and it's important for me to control RoCE v1 with v2 for research reasons, I suppose, at this point.
So Alex, we have some new stuff that's kind of touching on this.
Oh, I was hoping you're going to respond to that.
The latest version of Verbs that was released, like I think last week, has a way to query the RoCE GID type of each GID entry now.
Okay,
so you'll be able to discover the RoCE v1. We're also talking a lot about getting rid of RoCE v1, or at least turning it off by default. So I wouldn't rely on that as part of your solution. And I'm a little bit, you didn't elaborate on why you don't like lag. I think lag is probably your best bet.
Lag is, so the way I see it, lag kind of takes away some of my control as to like which port does the resource reside on, and like where the packet lives. So I don't have all the details because I never kind of focused on this topic technically, but it sounds to me, as a rule of thumb, I want more control instead of less. I'm open to kind of suggestions. Maybe there's something I'm missing there.
So we've been, there's been RDMA features over the last year or so that have been increasing the amount of control you have over QPs in a lag scenario. So in the current world, UCX can choose the egress port the QP is bound to on a lag, like the physical egress port.
Jason, how is it with the traffic class?
At the UCX level in Mellanox 5, I think you do it with a PRM command.
So, okay, so because up till some driver version, there was a round robin in the kernel on the TX port affinity, and now you're saying we can change it?
So if you look generally, and I think this even applies to some of the other RoCE hardware now, the lag egress port is selected substantially based on the flow label in the GRH. So it actually does hash the address handle and the flow label, and that gives you a lot of influence over the output port. But in MLX5 land, we can just set the output port of a QP directly. Obviously, the ingress on lag is controlled by your switch. So you want to make sure you have your correct headers and entropy and so forth to make that work. But you're stuck with that anyway in a multipath Ethernet network, pretty much. The downside of lag is that you have to go to the same switch. You can't, or at least you shouldn't, direct a lag to two different switches. So you can't do kind of the classical IB dual rail topology with lag.
Okay, I see.
Hey, Alex, what was the problem with setting both ports to RoCE v2?
Setting both ports to RoCE v2 kind of got him confused, because you have two ports with kind of like IP addresses in the same subnet. So if I remember correctly, the original symptom was that packets would kind of be launched and like timeouts and stuff like that. And I don't remember the specifics today, but there's a lot of details in the PR on how we found it and how you can like what's the trace and root cause for that. So basically, the problem was a conflict. It might be also related to the fact that we specifically have socket direct. So it's kind of maybe the two ports belong to the same physical port.
I don't know what you mean by socket direct, but if you put two IPs on the same subnet in Linux, there's a whole bunch of hoops you have to jump through to get the next step.
Exactly.
They're not hard. There's just a long list. Once you do those things, everything does work. It chooses the egress port based on the source IP you bind your sockets to. And as far as I know, that all carries over just fine into the RDMA world.
I mean, it doesn't it kind of take away control in a similar way that lag does? Because if you connect to somebody on the same subnet, what would how would you control like on which port it would go out?
When the NetStack stuff is all done correctly, it's all based on the IP address you pick. So if you pick the IP address of the first port, then every piece of your traffic stays on the first port, including ingress and egress. And similarly for the other IP.
But if we're not using RoCE lag, you would have two separate RDMA devices, right? So you can control which of them would be used to create the queue pair.
You have to do this as part of your CM process. You have to decide which of your two devices is going to win, and then you have to have redundant M keys and everything as well. For that issue, and I don't know if we do it for Ethernet, but there is a Mellanox feature.
I mean, this is what we do in UCX for the general case that you have two different devices.
Well, I was going to say we have a general Mellanox feature that puts the devices back together for RDMA purposes. And I don't know if that extends to the cases Alex is talking about, but certainly other cases it does. So you end up back with a two-ported single IB device that can share a PD, share QPDs, and so forth.
Okay, I mean, I will look into it because, as I mentioned, I kind of did this a while ago, and then I kind of had other top priorities. So I really have to get back to this, and I'll look into what you said. I might actually contact you directly, so consider yourself warned.
Yeah, okay.
Just a general comment that today the UCT level in RoCE does not use RDMA CM for MPI flows. So there is a lot of logic that we might be missing here. So I think at some point we've been postponing, but at some point we would like to have at least the option to resolve addresses in the UCT layer using RDMA CM and not just provide a remote.
That might run you into trouble if the UCT layer does not directly.
On that, I have to comment. Like today, this is a bit off topic, but the main reason why UCG still uses both UCPs and UCT is it uses UCP for connection establishment because it's just far too complicated.
Are you using the client-server connection establishment or not?
No, I'm not. I'm getting the worker address and exchanging it using modex.
Yeah, so still need it. I
Yes.
mean, yeah.
Yes, I agree. Okay, so I'll probably move on. Not much in UCP. I just mentioned we use UCT for most of the stuff. Actually, what Yossi was talking about with transport selection would be very helpful regardless of the UCC, UCG question we're going to talk in a different day. But clearly, it's very important to me to have the ability to have a clever way to control transport selection. Today, we have some small changes to support these new kinds of transport, which I'll talk about in a separate lecture. But basically, the only part we really use in UCP today is connection establishment. And maybe this will change over time with Yossi's changes. Maybe it won't. I don't know. And that's the comment in the slide. We use UCT directly. That's a really big off topic. This is the biggest spoiler alert I'm going to have in my slides, just because a bigger one would just cover the entire page. UCG is our work on groups or MPI collectives. We just called it groups to be more general, including some crazy MPIX neighbor all-to-all init now implemented. Well, not submitted in the, not in the repository yet. It's just a working copy, but we have a lot of work on this, and we do a lot of the changes in UCX to satisfy the requirements here, and I'll talk about it separately. This also pertains to OpenMPI support. We started with OpenMPI because we had some constraints on the business side, but I am certainly looking into integrating it for Mpich as well. And to show how serious I am on that, we initially planned the API to allow what the Mpich guys want, that is to use requests that are allocated externally and not allocated inside. But that's probably for another talk. What I wanted to say here is that I'm going to ruffle a few feathers probably with this change we want to submit, or at least propose, which is consolidating some of the UCX component. On the screen, you can see a list of quite a few components named UCX inside OpenMPI. Not to include, but you know it exists, also the ones under the OSHMEM tree. So basically what it means, if you remember the core count, I'm actually going to skip to the no, it's not here. Yeah, it is. So if I'm going to skip to the core count on this X6000 server configuration, we have 256 cores, which really doesn't like having 2 workers, 2 QPs, and 2 everything in OpenMPI or HyperMPI, which is the Huawei modified version. This means for us, we want to have some kind of consolidation. So this is a chart I put together saying, okay, basically Opal, I'm starting from the bottom because it's probably more convenient to read it this way. At the bottom, we have this Opal code, which already today has UCX initialization, because on a lower level, UCX is used for some OpenMPI internals, not just for application point-to-point. So what we want to do is we want to remove all the code doing initialization and cleanup and progress. There's an asterisk on this. I'm going to talk about it next. And remove it from OMPI level completely. Put almost everything inside Opal and have all the components, including PML, one-sided, this new collective component you can imagine we need in order to implement collectives, and presumably stuff for SHMEB also. We want everything to use this shared code in Opal. In addition, there is also some code about data types. I know a lot of work is done on this data type engine, and we're going to hear a lecture about it separately. However, today we have this code in PML UCX, which converts MPI data types to UCX data types. Basically, it does a bit more, but we want to put it in a place which also will be common. I created a new component in OMP MCA common, because Opal is too low for data types. Nobody in Opal knows about data types and packing and unpacking. So in common, I transferred most of the code from a PML UCX, which has to do with data types, and actually and free lists. One last thing, it also fills in the UCP and UCG params, which you can guess what that means, and feeds it into Opal. Opal doesn't know what will be the callback functions for stuff. So this structure allows us to have presumably one context, one worker, one UDQP when we start, regardless of how many components using UCX we instantiate on the higher levels. Yes, it has pitfalls, like what if you don't choose UCX at all? What if components want different things? It's not 100% of the scenarios will be covered, at least at first, but I feel like it's very, very important to avoid the unnecessary additional contexts and objects, especially in light of the number of processes running on the same machine and potentially accessing just one NIC below. By the way, another feature, I actually just finished implementing it last week, and it's in the proposed code, and it's in HyperMPI. We now have this will support as much as today it supports non-contiguous data types, for collectives it will also support like both non-contiguous data types and the user-defined data types and the reduction operations and all the stuff that MPI throws at you. So it's important for me to have the data type also common, because it means if you use MPI send and then MPI reduce with the same data type, they will actually use the same UCP data type and not duplicate that one. So that's important also. And clearly from like design and the code duplication point of view, it makes a lot of sense to consolidate the code. So that's important for me to mention. Open source policy, I'm just gonna put it out there. Probably nobody will be surprised to hear that like most of what we do, we contribute. Not everything gets upstream. We have some disagreements today, mostly regarding stuff that we want to do with the collectives, but that's fine. We're working out through those. Actually, not just UCX and MPI. Personally, like some CNEM stuff, and some of my team members help spec build the applications more efficiently to use UCX specifically, and some other packages we're working on, and I don't know, some stuff in related middleware like OpenPMIX. Few exceptions, you probably wouldn't be surprised with those either. Some hardware-specific code, it's out of my hands. Huawei decides what gets published and what isn't. Specifically, hardware that's not in the market yet, it's only for development. I can't do anything about that. Integration with some Huawei's proprietary server software, sorry. We're working with the storage guys to kind of use UCX as the underlying communication library for that. Clearly, well, not clearly, but it doesn't look like it's going to be public because of the storage stuff. And we actually have, like, as you would expect, there's a long list of requirements and a checklist for publishing code, especially in like code that is related to hardware, and that's kind of sensitive there. So there's a very long checklist, and a lot of people have to sign off before the code actually gets up into the open source, and that takes time. So a lot of the stuff is kind of still in transition. To be fair, with my colleagues in China, I actually have a bit of an easier time publishing code than they do. You know, crazy Israelis, what can you do? So that's I can say that's a fun fact maybe. As to the outline, I want to talk a bit about the roadmap. It's going to be vague, as a lot of the roadmap things are. So one, we work a lot. We try to work even more with other teams in Huawei working on specific hardware, and we kind of like, we have UCX as our hammer and everything looks like nails, and so we kind of try to slap UCX on different software doing communication and cares about latency today. So I just put a lot of images here. You can see on the bottom right a picture of the Huawei's RDMA capable NIC, which is like not available in your nearest stores, but is publicly available, and I've seen it in the wild. We work with the compiler team and some other performance libraries. Both our performance libraries team works with ARM to kind of work on that, but they also have some own in-house development, so that's interesting. And I actually have a meeting with them I think maybe in a couple of weeks, so they can kind of show what they did, and maybe we can integrate more tightly with them. Today we kind of use the headquarters in China kind of uses a tool chain with older version of that. We work a lot on accelerating UCX features we need, obviously, and this goes both ways. Both UCX could use more input and hints, and also I mentioned in the beginning of my talk, we could use more information from what UCX sees and kind of what's the pain points. I've given workshops within Huawei on how to profile UCX behavior and kind of what do the numbers say about the way your application runs, but we always want more. So some example, this is a picture I took at one of the, no, I didn't take that. I'm sorry. I took a picture. It was lousy, so I took the one from the official website. That's a Taishan server. That's an older model of what I mentioned earlier with the 4 Kunpeng CPUs. So a lot of cores. This affects a lot of things. So to name a few, and I'll give concrete examples later. To name a few, we work a lot on algorithm selection. It kind of sounds like it's focusing on collectives because I've been doing that for a long time. But even stuff to do with the transport, both the 1620, the one for Kunpeng, and some other work we've been doing on like even as low level as data structures. We're very much aware of like consumption and accessing remote cache and stuff like that. A lot of resource constraints, and we're also trying to amend that with the MPI consolidation I mentioned. Transport selection is very interesting for us. Today, we kind of started implementing some kind of transport selection, but we hope that we can put this in UCP at some point. Maybe that's closer than I imagined. And obviously, application performance takes a big place in my schedule, other than this week, which is mostly listening in and conferences. Some top features for high PPNs. So yeah, a high processors per node, shared memory communication enhancements. I'm gonna have a separate talk on that, but I would say I should say we had these we had this small patch for the spin lock to make it good for pthread for separate processes. So that's going to expand. I'm going to mention this later. Finer grained topology awareness within the CPU. So we care a lot today about the way the PCI is structured, or any system bus, CCIX, Gen Z, CAPI, whatever. We really want to see this go deeper into the like what's the placement in the CPU, and not only that, what kind of communication happens on the CPU in addition to like what we're communicating, because it is sometimes the case where when the code kind of treats this process is the only communicating process on the CPU, which is obviously almost never is the case. So that's this kind of topology awareness is something that we're actively looking into. That's actually in our team in China that's being developed, not in Israel. Memory footprint reduction, I deal with it a lot, both in like day-to-day code reviews and in the way I kind of help plan features that other people are working on. And obviously good old testability at scale. We're working on that. I'll show some, so later in the talks where I show numbers from our humble cluster in Israel, but Huawei has a bit more machines to spare for testing, and they do that. They just don't report to me, so I can't make them send me all the data they have. Some concrete example of what I want to do sooner or later. This slide is not as new as I would like. I've proposed it a while back, and I still haven't gotten around to actually do that. Concrete example, Kunpeng specific optimizations. We really want to improve the way we do locking between processes, because as you can imagine, when you have a lot of processes on the same CPU, this becomes a big deal. So there are quite a few publications on that, and we're not going to reinvent the wheel. We're just going to take some open source wheel and stick it on the wagon. There are some numbers here. I actually used this slide to show the guys in HQ the benefits, and there was some analysis here, and here it kind of looks out of context. But I will say it has a lot to do with CPU architecture and clearly the topology and the way the processes are arranged on the CPU. Very interesting topic, especially if you're a vendor with an abnormally high number of cores, which we happen to be. So this is something I am going to be looking into, and I will probably submit a proposal to put this in UCX, and justified by the other work we also want to upstream at some point, which is the shared memory transports. Optimizations, we have like this kind of is the more vague part of the roadmap. New ways to transfer data with existing interconnects means kind of getting more juice out of the existing hardware we have. We have pretty good hardware, both the ones we develop in-house and the one we buy from other vendors. New ways to overlap communication and computation. Actually, a lot of the work on the counters has this goal in mind. New ways to detect optimization and optimize common patterns. We really want to see more detection in runtime of patterns that we think we can optimize. It probably is very much related to what was mentioned earlier. Let's say we see that some alignment is beneficial. How about we do try to kind of work towards that? I'm not sure that particular example is feasible, but that's directions we're looking into. And obviously, new ways to help applications is always good and vague, and I can say it without anybody criticizing me. I do want to say one thing, like, because I'm not new to this forum, but most of my team probably is, and it's a newly formed team. So kind of a bit about them we appear to be a bunch of software engineers focused on networking. Our secret weapon is not the special sheep I used for the analogy on CPUs. We employ a lot of scientists, not computer scientists, including some professors, and we have a lot of academic operations. Experts on computational star, usually physics. So a lot of the work we do in the team is focusing on specific applications and developing stuff even inside UCX to help them. I'm not sure Michael is on the call, maybe he is, but Michael is actually working on specific optimizations we hope to put in UCX for WRF, for example. It sounds strange, I know, but I don't want to create so many spoilers in one lecture. So that's going to be down the road ahead. And actually, probably most of the people from my team on the call are on the more software engineering side, not on the scientific one. But to, like, as a general note, I feel like forums like SC are kind of preaching to the choir. So a lot of the work my team is doing, you can find in conferences like SciTech, which are more specific to a community. SciTech is aerospace, and the Open Foam Journal, you can imagine that what's the crowd like there. And a lot of the work we do kind of combines both worlds. So you will see more justification, like this application does something UCX doesn't agree with. We kind of try to make everything fit together. And that's this bit of introduction I wanted to do. Last thing before I have like a 5-minute question time, teasers about other talks. So we kind of wholeheartedly volunteered to give a lot of talks. So a couple more guys from my team will, I asked them to give a talk during this conference. So Shuki is going to talk a bit about how we collect and do something useful with the UCX counters with a Scorpion Vampire. This is a scary screenshot he gave me. So I'm not going to go into details. I'm just going to say you can join and tune in on day 3 of the conference on 10:40 Central Time. I'm going to talk together with Morad about one-to-many transports. This is a scary chart about the way we implemented the shared memory transports, but he will also talk about multicast and network one-to-many communication in UCX, obviously. And the last talk I have on the schedule is until UCC is available, the update on UCG. To those of you who haven't been following, I'm working on not just me, a bunch of people have been working on a library, doing collectives, actually kind of very much stitched into UCX. So if you can see this a big block hiding UCP, so that's us today. And in the future, we also have the UCC initiative coming along nicely, and Manju will present on behalf of the working group. That's all I have. Any questions? Thank you for listening so far, and questions, probably now is a good time.
Yeah, I have some comments on the slides, starting from the last one regarding shared memory. So we've kind of been trying to adopt XPMM to OpenUCX, since looks like it's gives more room for vendors to optimize memcopy for their hardware instead of just having everything in the kernel. Obviously, also you can avoid the overhead of system call and so on. So first, we plan to add this to Mellanox Software, the XPMM driver for whoever uses it. And also, you might want to consider adding some Huawei CPU optimized memcopy into UCS, like we have for other ARM vendors.
Yeah, the thought crossed somebody's mind in China. Not exactly my department, but yes, I appreciate the I appreciate the pointer. I think it's even underway, but I'm not sure about the status.
Also, you mentioned that there are some hints that in one of the slides that you would like to be able to provide to UCX.
Yes.
Do you have more details on that?
I have a few ideas I've been playing with. I don't have like a concrete slide on those. But for example, if you know a bit about the way the buffers are used, you can probably do better on some of the operations. For example, if you want to, probably the easiest one is, okay, you have some memory you want to share in the one-to-many scenario. So if you know the user is going to access the data as soon as he gets it, you have to create a copy. However, if you only want it for read-only, for example, presumably you can just share the buffer you already have. So that's obviously faster. These kinds of hints about the way the buffer will be used, and also hints about the send buffer and the receive buffer, allow us to cut corners. This is useful mostly for MPI, but also we found some examples in applications which kind of abuse memory to their end, and we would hope UCX would have special support for that at some point.
So I think it's possible to add these things to the existing NVX API. Obviously, we need to examine the exact use case and think of something generic. And maybe just for the example you mentioned, if you want the send buffer to be released fast or not, maybe the flag that we have today, fast completion, could help here. And if not, maybe we can think of something complementary to this.
Yeah, that's certainly the reason it's vague, is because I kind of haven't got to it yet. It's certainly like I certainly plan to like kind of bring it up as a proposal once it's more concrete. Okay.
Alex, I have a question.
Yeah. Sure, go ahead.
User space locking library. So my question is, it's some external library, and users, why you don't put it locking inside of UCS since we already have?
So today we use the locking in UCS, but I learned that the art of good user space locking is a library in itself. So I'm not sure we really want to kind of merge the entire code into UCS, but rather maybe just have an external dependency available at compile time.
Essentially, you have upper layer using different locking, user space locking, and you want to have an option essentially to use UCX with the same locking mechanisms.
So today, the short-term goal is to use this locking for shared memory communication. So it's not even something I provide to outside UCX. It's just for internal use. But clearly, like if the application is using some kind of locking, it makes sense UCX will use the same library, or I don't know. This is to be checked.
Okay. As for memcopy, Yossi commented, definitely we have now multiple memcopy implementations, pretty much per microarchitecture for ARM inside of UCX. My overall advice to vendors actually, make sure to upstream your optimized memcopy to glibc. Eventually it will show up in upstream, and we don't have to deal with this. But the reality is that it takes years and years to get.
I don't suppose you know what's the status with Huawei being happen to be an ARM-based vendor.
Yeah.
Do you know if they have some headway on this? I don't talk to these guys a lot, not because
I have no idea.
Okay, I'll kind of try to check internally.
Like I can tell you from UCX experience, for ThunderX2, Marvell guys implemented their own memcopy, which they upstream to glibc, but again, it takes forever to show up in distribution, so they re-release the same memcopy to us under different license and put it in UCX. Oh,
I see.
Like recently we merged like Fujitsu version, not Fujitsu, it's from Stony Brook, but for Fujitsu system. So we have more and more of this. I remember too, I think there is additional maybe implementations in UCX.
Okay, I'll look into it. Sounds like it's something I can actually do in the short term if it already exists.
Yes. And Yossi, you mentioned XPMM. So is XPMM now distributed as part of Moffett or whatever you call it now?
We're adding it to the next version.
Does it mean that you guys are going to solve the problems between IB locking and XPMM?
I mean, this is not a problem for UCX at this point, so probably this is not in the plan unless we find like some scenario where we really need it for UCX.